Perfect. Thank you very much.
No problem.
Thanks, Jim,
Yeah,
for the
you
introduction.
don't need to. Okay.
Yes, so sound is good. Now I'm waiting for the slides to show up for you guys. Hi, everybody. My name is Ole from Zealand. I'm working for a company called trinckle. Trinckle is a software company, and today I have the pleasure to talk to you about a use case we have developed over the past years with a medical client of us, a company called Mecuris. I'm very glad that this stage is here for applications in AM, in this case now in the medical field. I personally come here to Formnext mostly to see applications of 3D printing, not only hardware, software, materials and so on, but mainly applications. So I think it's a great thing to have a stage dedicated only for applications, and I want to share an exciting one with you. I was supposed to be here with my client, Mecuris. Unfortunately, the product manager couldn't make it to Frankfurt on short notice, so sorry guys, you have to live with me for the moment. I try my best to introduce the whole project to you guys and tell you a little bit the road that we have went through the past and what we are still have ahead of us. So I'm talking about orthopedic and prosthetic solutions enabled with AM, and I want to start with the question why this is actually a good idea, why the O&P sector and digital tools belong together. So one of the first arguments that come up why you should dive deeper into digital tools is if you compare to the traditional handcrafting job in orthopedics. So there is a lot of plaster and handcrafting involved, and if you think of the reproducibility, that's a major aspect that you have an advantage in digital tools. You can create the same orthoses over and over again in the same quality. So especially for an adult that needs after a while a new orthosis, you can reproduce the same product once again. And if there are tiny adjustments to make, that is very easily done. In a digital world, it would be way, way harder if we still talk about conventional handcrafted manufacturing. And as well, of course, you guys probably know that certifications and quality processes are a major aspect in the orthopedic world. And of course, documentation is a lot easier if you have a nice digital workflow that you can document. Very important for this field of business. And of course, the digital tools give a lot more of design freedom. Yeah, that's a topic you always hear in the additive field. I will come back to that on the next slide. Additionally, we talk about patient compliance, a term that I learned anew, but it has to do with the acceptance of such an orthopedic device by the patient. Yeah, I learned that a couple of decades ago, people tried to hide as much as possible their prosthetics or their orthosis devices. Nowadays, luckily, we are more in an era where people try to co-create their designs of their orthoses, and it means something to them if they have the chance to customize it a little bit. And the digital workflows, they enable patients to do this, so this is a major benefit, making the devices also more acceptable and better for the patients. And of course, the digital workflow, they can save a lot of resources in terms of materials, but also time. If you go to an O&P company, you will see a lot of plaster and carbon fiber and so on being thrown away, and the digital processes can help to save a lot of this material, but also time for the technicians. And this brings me to the additive field in particular. Since in the additive world, you can start a print shop and do something else. You save a lot of time for the technician. Of course, the printing itself also takes hours. Yeah, there is no counter argument for that. But in this time, the OP can do something more meaningful and have this time available for other topics. And with 3D printing, orthopedician technicians can be very precise in their production. Yeah? So handcrafting, I mean, there is a human error in this. You can only be so good as the handcrafting skills and processes allow. In digital production, in additive manufacturing, you can be more precise and deliver higher quality devices like these here that I have in my hands. And even more important, you can keep the consistency. Yeah? So if you do everything handcrafted, yeah, of course, you will never be able to do exactly the same product the next day if you want to repeat it. And talking about the complexity, of course, with 3D printing, you can be much more detailed in terms of lightweight design or custom design, etc. But it brings me to a very important question. Does this mean that every orthopedician actually needs to be also then an engineer, a CAD designer, an expert? If that is the case, then we have a big problem because there's the next bottleneck. And this is why we started this project with Mecuris, our customer from the orthopedic world, to solve this hurdle, to solve this bottleneck. And on the Mecuris design platform, the Mecuris Solution Platform, you find a digital workflow that enables every orthopedic technician to do those designs without getting dragged into this rabbit hole of CAD design and expertise. So this platform tries to solve this problem, make the whole design process more user-friendly, and really guides the user step by step through the process. So in this solution platform, you find 3 stages. And the last stage, this is actually the one that was developed by trinckle, where we integrated with our software technology into this overall process. But all 3 process steps are interesting. So it starts with a scan. The scan of the patient's leg or arm is the starting point, and then you try to correct the scan a little bit because you probably have not captured the right position or orientation of the arm or hand during the scanning process. After that, it comes into the modeling phase. Modeling means you want to add a little material here or reduce a little bit material there. So you end up with what Mecuris calls the functional form, so basically an adapted scan. And with this scan, we run into the creation phase. And that is where it's getting exciting for me, because this is what we developed from trinckle side, the Mecuris 3D Creator, where we enable everyone based on this functional form to develop a design either for a hand orthosis or leg orthosis or other orthopedic products. A little bit more in depth. So it starts with the scan. To make this accessible for algorithms, we need to set reference points on these scans. Every orthopedician knows which reference points are really needed. He will mark them on the scan, and this will be the base for the correction of this scan. So in the next step, we will have this slight correction. Maybe the scan was done in a position that was okay for the patient, but you don't want to achieve that at the end. You might want to achieve a corrected orientation of the scan. So that's step 2. Third step, like I said before, sometimes you might want to add a little bit material or make it even a little bit thinner. Maybe you want to add something for the toe area, for instance. So you might want to adapt the scan a little bit to end up with a functional form, which then goes into the design phase. And there it's getting interesting for us. What does the orthopedician do in here? First of all, he starts with a scan. So this is not my one, so it does not fit perfectly, but to explain this a little bit. So we have the functional form of my hand, of my arm, and the first thing that the orthopedician is doing, he will create this cut line, this trim line here, and there he has the free choice to design whatever design is or device is needed. So the orthopedician, she can create those trim lines, cut out whatever material is not needed and not wanted, and then end up with let's say, the outline of the design. So basically, the orthopedician has really the chance to design a complete new product that for this individual patient is needed. After he's set this trim line, the next things would be adding components like strap holders here to attach a strap, or for instance, set this perforation, yeah, for a better ventilation of the part, for more comfort for the user. Again, here on this one, you see again strap holders, for instance, perforations. Somewhere here, I'm not sure if you can see it, but this is a arm orthosis for a kid. So there's a little dinosaurs on it as well. So might be a little bit naive from us, but we realize, or Mecuris realized, that even those little tiny individualization steps make it more accessible or acceptable for the patient. So in the world of orthoses, this is what we have been doing with Mecuris over the past years already. So job is done for the very easy, simple orthoses as you see it here. The next thing we are working with them right now, and this is where trinckle gets involved again, is adding joints to those components. That makes it a lot more complicated already. These mechanical components, they need to be positioned very, very precisely. And here it's very important to have the right orientation in the walking direction, to set the rotation point in the right spot, and then create these pockets for the joint exactly parallel on top of the functional form of the scan. Yeah? So you cannot just place this one, and then separately the second one. It has to be precisely parallel, and you have to adjust that on top of the functional form. So that's a very delicate thing. We learned that if you do that in a manual design process, probably people will need 7-8 hours to do it really, really right. And this is something we need to speed up to make it accessible for the orthopedician. And here you see a little bit how this works. So you basically select some axis, you orientate it in walking direction, you make sure that the rotation point is correct, and then it places those pockets exactly on the outline of the functional form, and then you set the trim line accordingly. So then with this step now, in the future we will have also access to everything that has joints. But we also want to move into other categories, for example, prosthetics. So here, for a fresh amputee, this check socket is important, and such a check socket has this adapter part which is needed to connect it with a artificial leg. And this is something you need to position, and we do this again, orientating it with the right axis, connecting the adapter to the shaft, and then setting the trim line for the check socket on the upper end. So we are moving into new categories here. This is what we are working on right now at trinckle to help to make these products broader and enrich the portfolio. So at the end, with this process, we try to give the orthopedician the design options to create their own parts, the better product, orthopedic product. So we want to give this design freedom to the orthopedicians here in this case, and not only present a few templates to them. So these are some photos of the final result. We have some more at our booth here in this hall actually. And yeah, to wrap up, I also want to talk a little bit more about trinckle and what we're doing in other areas. So right now I was only talking about one customer case, which we do in a partnership with Mecuris. We not only work for Mecuris, we do a lot of projects in the area of medical fields. So for example, not only the medical end parts, but also the tools for orthopedicians. In this case, the shoe lasts designs for the orthopedician shoemaker to create custom products. But we also do it in other industries, in the field of robotics or the field of automotive manufacturing, for instance. And we always do this based on a software platform which we call Paramate. So this is the base for all these design automation use cases that we have and we help our clients to automate with. Basically, the idea is always there is some kind of input data. In the case of orthopedicians, it's mostly scan data, but it could be basically anything. It could be image data. It could be a user interface with sliders and numeric inputs. It doesn't really matter. What we try to get is this input, then apply a set of rules, generate automatically following these rules an output which is ready to print and optimize for the printing process. So this is based on Paramate. And just to give you some ideas, very, very short, we're looking, for example, at end-of-arm tools in robotic cases, individual ones for each single use case of a robotic. And just to give you an idea how this works, so a similar process, we try to make this design easier. So you upload the part that you want to lift with a robotic hand. You just decide here, 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 and here, I want to grip this part. And then automatically we do a triangulation between those points. So all set on mathematical rules. And then based on these triangulations, we create a structure in between and automatically create a full end-of-arm tool, which would take an experienced engineer at 8 hours roughly to achieve. So products like this, heavily customizable. This is what we are doing from the software side, supporting these kind of businesses. Another component would be, sorry, a little fast, would be, for example, jigs like this in the automotive world. Here it's all about putting those emblems on the top of a car, for instance. Again, how do we do it? Here I try to visualize this functionality. So it's always the same task. We have some kind of counter geometry freeform, and we want to apply a sheet on top of it. It should follow this functional form. This is a typical project that we do. And the last one, and then with this one I want to end. You might have seen those parts from the Deutsche Bahn, braille sign for blind people to navigate on train stations. There is always individual content guiding blind people, handicapped people through train stations. So you need to provide that in braille font. Each sign in each train station in Germany is different, obviously. Here it's main station, main street, 250 meters to the left, or whatever street, 350 meters to the right. Always individual content. We automatically convert that into braille font, and every single printed aluminum piece, and we're talking about 30,000 pieces for German train stations only, is individually and designed automatically with our software. So these are a couple of examples of customer projects that we've done in the field of design automation. The medical field is especially interesting for us because it's always about individual patient-specific products. And if you want to see a few more, please visit us here in this hall at 11-1 D39. We're here the whole week, so if you want to discuss maybe a design project that you have in mind or a problem that you have to solve with repetitive design tasks, please approach us. We're always happy to discuss. Thank you very much for your audience. Thanks.